What I want you to do at the beginning of this video is just pause it real quick and just jot this property down right here. It's not used that often, but I'm going to give you a little property that we're going to explain more on letter B. For part A, we're supposed to find the polar area of this shaded region. Now, some of these polar area ones, we will get the hang of this. Sometimes they're straightforward and you can kind of see it right away. Sometimes there's more than one way you can approach it. Sometimes there's a little bit trickier right there. Here's what really helps me. Now, we're going to use this formula, 1/2 r squared. It's always a d theta problem, so those are angles attached to our integral there. So that's what we're going to use is that formula to get the polar area. What really helps me on most of these problems is to take whatever angles they give me and actually draw those in. And we're going to like treat them like windshield wipers that go across our windshield or that go across our actual shape there. So if they give you thetas, draw those thetas in. And then let's think about this, right? So if I were to use my windshield wiper idea, if I go from theta equals 0 to theta equals 2 power 3. So there's my windshield wiper, starts down there, starts raining, and then boom, we're gonna just windshield wipe it right here. This could give me this area here. So I'm gonna use my 1/2 r squared formula. And then the r that you're using, notice this curve right here is my r equals 2, 1. That's what we're talking about. And then this one out here is this more complicated equation. But right here, we're just worrying about that r equals 2. That's that circle. And so if I integrate 1/2 r squared using r equals 2, so there's my 1/2, then that 2 squared is going to give me the 4. And I'm going to integrate that from 0 to the 2 pi over 3. That's going to give me that top shaded region right there. And then I realize that it's also symmetrical. So I can just go from 0 to 2 pi over 3 and then double that. That's going to give me the top and that bottom portion there. So that's where I did the 1/2 r squared from 0 to 2 pi over 3 and then doubled that. And that gave me the top region and the bottom region. Now, what I'm missing still, I'm still missing this little sliver right here. Now, if you look at this little sliver, this portion of this outer edge, this outer curve is on this giant, bigger equation. That's on this guy right here, this more complicated 3 plus 2 cosine theta. So to get this little sliver, I'm going to do my 1/2 r squared formula, but I'm going to go 1/2 times that more complicated equation squared. And then if you just think about the windshield wiper idea, you're going from this windshield wiper, the 2 pi over 3, to this windshield wiper right here, just windshield wipe that, but then you're just traveling along that curve. So we got that equation in there, knowing that we're just going to keep it to that portion of it, and then from this angle to this angle. And so this is a calculator problem. So you can just math 9 both of those integrals, and you should be able to come up with that decimal answer right there. Now, letter B. Sometimes these giant paragraphs, they look confusing, right? So as I'm just kind of reading through there, it gives me, got this velocity, I got this R, and then I'm just seeing this stuff right here. Now, we know when we see this notation, it's some sort of derivative, right? So if they give me R and then I see the derivative notation, hey, let's just take a derivative of that thing. That's all we're going to do there, okay? Now, since they tell us dr dt is equal to dr dt, normally on like a dr dt problem, we have to worry about tagging on a dr dt or a d theta dt or a dx stuff like that. But since they just tell me the dr dt is the same thing as dr d theta, that means when they tell me to find the dr dt, that's the same thing as finding dr d theta. So this is already r's in terms of theta. All I have to do is take the derivative of that equation. That's it. So you see the derivative notation. Sometimes we just kind of ignore some of this other like hoopla they try to throw in us. You see the derivative notation, just simplify it for yourself. Just take the derivative. So we know the derivative cosine is going to be a negative sign. And then here, so we did that first part. All right, we found the value of this dr dt. All right, now it tells us at the pi over 3. So which means we're supposed to take the pi over 3 and plug that in right there. And then that's going to give us this negative radical 3 number there. So that's the first part of that. But then it says interpret your answer in terms of the motion of the particle. So here's what I want to do. Now this isn't, I've only seen this happen a couple of times there where they ask us that specific concept. But here's what we want to kind of have down. What you need to do on those kinds of problems is compare the signs of the r and the dr d theta. If they have the same sign, that means the particle is moving farther away from the origin, either both positive or both negative, you're going farther away. If r and dr d theta have opposite signs, then the particle is moving closer to the origin. And I guess, let me just try and explain that in terms of like your normal derivatives and slopes that you're used to, right? And so let's just think of something like, let's just think if my y is positive, and I give you like dy dt is negative. So if I have a positive y value, so it's above the x-axis, and then I tell you that the dy dt is negative, that means your y's are decreasing, which means it's going downward. All right. So if you're up here and you're going downward, those are opposite signs. Look what's happening to your thing. You're getting closer to that origin. Whereas if your y is positive, and then let's say I give you that the dy dt is also positive. So they're the same sign. So they're the same sign that if your dy dt is positive, that means your y's are increasing. So which means if they're the same sign, you're getting farther away of that origin right there. So that's when, it works the other way too. Like if your y is negative and your dy dt is positive, they're opposite signs. That means you're getting closer to the origin. And if your y is negative, you're below the x-axis, and your dy dt is negative, they're the same sign. That means it's getting farther away from the origin there. So we're just going to have that property down. That's what helps me remember that property. And so when they asked me that, I already knew the drd theta was a negative number. And then what I also wanted to figure out at that power 3, I plugged the power 3 into my original function to figure out what that r was equal to. And then since the r and the drd theta are opposite signs, that means my particle is moving closer to that origin right there. So I'm not even sure. I don't know if I have that in your blue packet or not. You might just want to double check and just maybe add that in your blue packet somewhere. And I think that'd be beneficial. And then the last part of this, it tells us the dy dt equals dy d theta, and then wants to find the value of that at power 3. So all I got to do now, see, the thing is here, this was a dr d theta. So that's just your derivative of r equation. Now here, if I want to do the derivative of y's, the problem is I don't have a y, but you just got to remember your pre-cal properties that we gave you in those extra videos right there. If you have to get an x involved, use x equals r cosine theta. If you have to get a y involved, you're supposed to take the derivative of y's, and you don't have a y equals something in that problem. Let's just start with your pre-cal stuff, the y equals r sine of theta, and then we know the r, so I can plug that in right there. Now, here's what this was to me an easy derivative, so I practiced this without the calculator, but this is on the calculator part of the test. You can actually just mathate this function at power 3. It's going to give you the 0.5 number. But so two ways you could do this one. If you want to practice it without the calculator, just take the derivative of that, do a product rule, right? And then you plug in the power 3, you're going to get this 1/2 answer. Or you got to remember, if you're on the calculator part of that test, what you could do, math 9 is your integral. If you hit the math 8 button, this pops up, and I already got that in there for you. You can rewatch that graphing calculator video as well to refresh how to do this. But if you hit the math 8 and then you type in that function, it will take the derivative for you at that pi over 3, and that will give you like the 0.5 right there. So again, if you this is your y, you type that into the equation, math 8, it will take the derivative of that for you, so you won't have to do all that, and then you'll get that same 1/2 answer right there. But you should still show yourself, you still got to show what that y is equal to, and then you could write down, hey, the derivative is equal to this, and then they're asking you to interpret your answer. So this is just your y's, like y's and x's is just like your normal stuff, like you're used to right there. So since your dy d theta is like a positive number, that just means your vertical component of that velocity, you're going to point up, and you got that magnitude of that positive 1/2 right there. Blueberries and blackberries.